Okay, so very first thing when you guys came in August, whatever, was it the 13th? I don't know. We started with order of operations. So that's where we're starting here. So you do exponents first. So 3 times -6 plus 4. PEMDAS, that's perfect. And then multiplication is next. Positive times a negative is a negative. And then add those together, -14. I'm going to attempt to do this whole thing with no calculator. We'll see how it goes. Okay. Then next one, we have multiplication here. So that's -12/4. However, what do we do when it's minus a negative? This is one of the things we worked on. Plus, beautiful, great job. So I put them both to pluses and make that +6. Excellent job. Love it. Okay, and then we divide. We have -12 divided by 4 is -3, remember? So the negative stays out there because there's one of them. And then add the 3. All right, and we worked on some absolute value like this problem. I'm going to leave that negative in the front. Don't forget that he's out there. 18. Okay, and then I'm going to say -2 minus. And the very first thing I'm going to do on this problem is take the absolute value of -6. Absolute value of -6 is beautiful, +6 -2, but I'm going to leave that +6 in the parentheses with the -2 that was there before. Okay, then I'm going to do the parentheses here because 6 minus 2 is 4. Okay, and this is really good. I like this problem because you'll see in a second, combine the bottom. This time I have a negative in front of the fraction and a -6 on the bottom. And those two things, two negatives cancel to make a +3. Okay, and then number 4, last order of operations problem. This one's spicy. It's got absolute value in a cubed in the same dealio. I'm just going to do it very gradually. So I have -3 times 6 is -18. And then we have this minus a negative. So I'm going to make that +4. And then plus, and then I'm going to do this in 2 steps. I'm going to take the absolute value of 3, which is +3. And I'm going to put that in parentheses. That's going to show that I did the absolute value. Does anybody know what 3 times 3 times 3 is? 7. Beautiful. Does anybody recognize that tone that they could come put their phone on silent? Okay. Anyone suspect that their phone might not be on silent? Do you want to come check it? Anyone experiencing extreme paranoia? I need to check it. It means that you're like, kind of unnecessarily worried about it. I want to tell you that I appreciate all of your diligence with the cell phones. Really do appreciate it. Okay, now back to math. Later that day. Do you guys have any questions about number 1 through 4 before we move on? So we understand what minus and negative does. We understand what absolute value does. Understand PEMDAS. That's kind of what that's looking for in that section. Okay, now we're going to go to the exponents. And you're like, Mrs. Talbot, we started out the chapter with this, and this was the very last thing we did. I know, but it fits so nicely in this spot on this worksheet. First of all, you must know that Miss Rice and I are all about making things look pretty, and this looked pretty right here. So this is where it's going. Okay, this is going to be a little bit spicy. I already know that. It's okay, we're going to go slow. Okay, number 5, 4 to the 0. So a reminder, yes, 1. Anything to the 0 power is 1. Nothing more to do there. Literally just 1. It's the best problem of the whole thing. Okay, now 3 to the negative 1. This one is a reciprocal because it's a negative exponent. So negative exponents are reciprocals. Yeah, so I'm going to write it in 2 steps. You're correct. The answer is 1/3. I'm going to write it 1/3 to the 1. And then I'm going to simplify that to 1/3. If you see that's 1/3 immediately, that's totally fine. I just wanted to show you where the numbers went. What happened to the 1. Okay. Now, the only reason I threw number 7 in here was to not override all of your knowledge of exponents by just throwing a negative in. This problem is not a reciprocal. This one is a reciprocal. This one is not. Do you see the difference between these two things? This one has the negative in the exponent. This one has the negative in the base. This is literally just -4 times -4, which is 16. Don't override all those beautiful files you have in your mind about what to do with exponents just because we learned something new. That new thing only applies to negative exponents. Okay, now number 8. This is a super important problem, like super important. Do you all see that this one's going to have a reciprocal involved? Okay, if you hear me say nothing in the next 2 minutes, it's that the p to the -2 and the 3 are separate things. They're separate. What that means is the 3 does not have a negative exponent. It stays where it is. The only thing that becomes the reciprocal is the part with the negative exponent on it. Let me say that again. The 3 and the p to the -2 are separate. 3 is actually to the 1 power. We're just too lazy to write the little 1 there. We don't. Okay. Number 9. How are we 9 problems in already? Number 9. Okay. Speaking of the little power that we don't write, this little n here without anything has a 1 on it. We can't forget about him. Okay. So what we do is we multiply the numbers. So multiply the constants, add the exponents. Multiply the constants, add the exponents. Anyone like already at the bottom of this page just waiting for me to do the scientific notation? What's yeah, I figured. Okay. All right. So same exact thing. Let's go again. Multiply the numbers. What's 4 times 2? 8. Beautiful. Okay. Now this little x guy here, he has a 1 on him that we just don't write. And we add the exponents. What's 1 plus -3? Beautiful. Okay, now I want you to think about number 8 right above it. 8 and x to the -2 are separate things. So only that part is going to be the reciprocal. and 8 stays on the top. I've said a lot of stuff. I want to pause here. Anyone want to say, add, ask anything at this moment? Okay. Four p to the fourth to the third. So when you have something to a power, the exponent part is easy. You multiply it, but you also have to do 4 to the third. It's like distributive property, but it's not really. So 4 to the third, p to the 12. 4 to the third, p to the 12. 4 to the third, I believe, is 64. Okay. Okay, now number 12. I'm going to do the same thing. I'm going to do this little rainbow dealio that I do. That's for my visual learners out there. I need to make sure to take everything in here to the third power. So I have 3 to the third. I have y to the third. Do you guys see the y to the third? Do you see the little 1 there that we just don't write? Okay, and then x to the negative 3. So this is little 1 times 3, little 1 times 3, negative 1 times 3. Okay, now these guys are all separate from each other. So 3 to the third, y to the third stays on top. The only thing that gets the reciprocal is the negative 1. And then we already figured out earlier, 3 to the third is 27. Are we getting the hang of the negative exponent deal? Okay, last two. This one has all positive exponents, so I'm going to write it out and look for giant ones. That's going to be my strategy there. Okay, giant one spotting. I see we have one set of A's we can cancel. And we have two sets of B's we can cancel. But also 4 over 2 can be reduced. So divide by 2. So on the top, I'm left with 2a to the third. On the bottom, I'm left with b squared. It's technically 1 times b squared, but I don't usually put the 1 times in front. If you do, it's totally fine. I would not mark that wrong or mark it down in any way. Now, I have some kids in here that are pretty advanced. Does anyone think that they could just go from here to here without that? And if you can, that's okay. It's okay. I'm just showing this because it's the first time, but if you can go from there to there and get the correct answer, I'm totally fine with it. Okay, last one of the exponents. Sorta, because scientific notation problems are technically also exponent problems, but you know. Totally different. Okay. Number 14 is the same as number 13, except for we need to fix these first. So I'm going to say, okay, I need to fix this guy and I need to fix this guy. Okay. The 3 is on the top. It's going to stay on the top. And this guy, I'm going to fix by taking his reciprocal, and his reciprocal means moving him up. Two is on the bottom. I'm going to fix this guy by taking his reciprocal and moving him down. I think that this is a really good problem for everyone to see exactly what happens with the negative exponents. They switch spots. Okay, now I'm going to treat this problem just like number 13. I fixed all of the negatives. Okay, giant ones here and here. And I have 3x on the top and 2y cubed on the bottom. Okay, anything from the section from 5 through 14 that you want to ask me? You're going to get a lot more practice with this with the digital escape today. So this is what you're going to be doing in your groups as soon as I'm done talking. All right, let's move on to scientific notation. Okay, here we go. Write each number in scientific notation. This is probably where you stalled if you started on with the review notes. Okay, so first thing you do is put a decimal in the right spot. Since there's no decimal, it goes at the end. And then I need to move the decimal until I get a number between 1 and 9.9 repeating. Okay, so let me explain. I'm at 2,900. If I move the decimal one spot, I have 290. If I move it another spot, I have 29. Do you see what I'm doing? Mm-hmm. And then if I move it another spot, I have 2.9. That's what I'm looking for. I'm looking for a number between 1 and 9.9 repeating. So I say, okay, 2.9 times 10. And then the exponent is how many spots I moved it, which is 3. Okay, now where do I want to move the decimal between what two numbers in this one? 3 and 0. Beautiful. Okay, so 1, 2, 3, 4, 5. And this one, because it was a little tiny decimal and I made it bigger, I have a negative exponent. So times 10 to the negative 5. So if you want to think about it, moving the decimal this way is a positive exponent, and moving the decimal this way is a negative exponent. If you want to think of it that way, you can. Do you like that? Okay. All right. Now, the next, you might have, some of you guys might have figured that out, but then got completely stuck on 17 and 18. Okay. Do you remember? I'm going to scroll up a tiny. Do you remember what I said to do right here? What did I do with the numbers? Multiplied them. And what did I do with the exponents? Added. Beautiful. That's exactly what we do in this problem. This problem is a multiplication problem. So you're going to do 9.8 times 7.5. So multiply the numbers times 10. And then add the exponents, negative 3 plus 1. I'm showing all my work here because it's the review notes. So I want you to see exactly what happened. Okay, so calculator time. 9.8 times 7.5, 73.5. Okay, now pausing. Is this number in scientific notation? No, I mean, sorta, except it didn't follow the rule where the front number needs to be between 1 and 9.9 repeating. So I have to do what I did here. I need to move this decimal down a spot. If I move this decimal down one spot, like I did here, I have to add 1 onto the exponent. Let me say that again. If I move the decimal down a spot, I have to add 1 to the exponent, just like here. Moving down adds to the exponent. So 7.35 times 10 to the negative 1. Okay, now, knowing all that you know here, what do you think we do on number 18, Landon?
Divide the 8.33 into 2.8 and subtract the negative 5 and negative 6.
Beautiful. Okay, so divide the numbers. Subtract the exponents, but be really careful. Do you guys see how super careful I was right there? Do you see it? -5 minus -6. If you want to, you can write that if that makes you feel better. Okay, so back to the calculator, 8.33 divided by 2.8, 2.975. Oh, we got lucky on this one. Does anybody know why we got lucky? Yes, the decimal point's already in the right spot. Okay, and then we come up here and we say, oh, it's minus and negative, and we make that plus. -5 plus 6 is 1. Did that clear up the scientific notation for you, I hope? Okay, we're going to practice it more. It's going to be fine. Yes, honey. Real quick. Like the wind. All right, flip to the back when you're ready. All righty. Next set of problems, we have some function machines. Can you guys tell the difference between a forward and backward function machine? What is number 19, forward or backward? Backward. Backward. And these are all forward. Okay, backward function machine. You don't plug it in, you equal it. So -3 equals 4x plus 5. Again, yes, honey. Excellent question. So it's the notation. It says find x if f of x is -3. So this is saying find the input if the output is -3. So this is input this is output. This would be a great problem for your note card, just saying. Just so that you can note the difference between the forward and backward. So when we have a backward one, we don't plug it in, we equal it, and then we use our inverse operations to solve for x. Okay, now these guys down here, these are all forward function machines. So you're going to take 4 and you're going to plug it in. You're going to input it into x. So you're going to say f of 4 is negative 4 plus 3 plus 5. And then this is the function machine here. You're just going to do the machine. So negative absolute value of 7 plus 5. What do we do if the negative is outside? Is it positive 7 or negative 7? Negative 7. Beautiful. Negative 7 plus 5 is negative 2. Okay. Number 21, I'm going to put 5 here, here, and here. I'm going to put 5 everywhere there's an x. F of 5 equals 5 squared minus 6 times 5 plus 6. $25 minus 30 plus 6. I believe that's 1. Look at me go at 9:01 a.m. Yes, honey. Will this be negative 5? Did you do 30 minus 25 in your head? Oh, this is an excellent question. Okay, PEMDAS. Let me show you what it looks like actually. So multiplication and division are actually on the same level, and addition and subtraction are on the same level. When you have multiples of these, you're supposed to go left to right. Okay, I love that question. Okay, so that's a 3. That's going to become a 3. That's going to become a 3. F of 3 equals negative 2 times 3 minus 3. Negative 6 minus 3. Negative 9. Oh, that might be one of my favorite questions of the whole thing. Okay, last one. That's going to become a negative 6. That's going to become a negative 6. Okay, what you want to do on this problem first is inside the grouping symbols. So make that negative 2 Okay. Two very important things. I want to slow down just a little. Two questions I have for you. What is the absolute value of -2? 2. And what do you do when a number is just glued on the front? Yeah, that's times, right? Super important. We had some questions about that on the first quiz. What do you do when a number is just glued on the front? It's times. So this is 3 times 2 minus 5. We got a lot of ones in this review notes. A lot of ones. Okay. Any questions? Yes, honey. You're good. Okay. Any questions about function machines, forward or backward? All right. Now let's move down to these. We're actually on number 24. It doesn't ask us for the domain and range, but we're going to do it because we need to practice really bad. And it's not just you guys, all of my classes need to practice. It doesn't even matter what math you're in, everyone needs to practice. You not heard those words before? Okay. So first, let me ask you if it's a function or not. Yes. Okay. So yes, a function. Because it's a graph, we say passes the vertical line test, which I'm not going to show on this picture because I would just have a lot of vertical lines on there. Okay, now we're going to do the domain and range. I'm going to do it with a colored pencil. You can just sketch on your paper. You don't have to do a colored pencil. Okay, so domain, just to remind you, domain is X. And so I notice that I have an arrow going forever this way. And the V shape covers this whole area and goes forever that way. It goes forever to the left and forever to the right. What is that called? Beautiful. Okay. And you can write it. You can write the words, all real numbers if you want. I'm too lazy. I write the fancy R. Okay. Range is the Y's. And I see a very clear bottom to this graph. I'm going to make a dot there. And then I notice it goes up forever. This is an arrow going in one direction, not an arrow going in both directions. So I start with Y. It's going up, so greater than or equal to, and then the lowest value is -1. I realize this is the spicy kind, but we need to do it. Okay, one more question. Yes. Look at the crocodiles. Do you see the crocodiles? Okay, so this arrow is going up. So in your mind, you have to say up is greater than, and then you look at the crocodile and you remember greater than. If the arrow was going down, you'd say to yourself less than, and then also, it's never a bad thing to put on a note card just to write yourself a greater than and less than on there just to be safe. Okay. Last problem. Is this graph a function? No. Okay, now this is a hint for you for the test. when something fails the vertical line test, they're gonna ask you to justify that. What you have to do is just draw one vertical line where it would fail. So you just have to pick a spot where it would fail. I'm just gonna pick right here. Draw in one vertical line and then indicate that it's hitting twice. That would be enough justification that your vertical line test failed. It only needs to fail one time to fail. So you just have to find one spot where it would fail and draw it in. Does that make sense to you guys? Okay, now we're gonna do domain and range. This one is not as bad, although it's kind of small. I'm gonna zoom in. Okay, so the very left point of my graph is here. And the very right point of my graph is here. So this is the most left it goes. This is the most right it goes. This time we don't have any arrows. We just have it in between 2 points. So we write it like this. -1 is less than or equal to x is less than or equal to 2. Notice it's closed at -1 and closed at 2. Okay, now we're going to do the range. Here's the very most bottom, and I'm going to try to exaggerate the fact that it's open with my colored pencil here. And there's the very top. The bottom is -5. The top is 2. Working with y's. On the bottom, it's open, so I want to make sure to not put the or equal to on because it's open in that spot, but it's closed at the top. Okay, now can you flip your paper over when you're ready? Flip your paper over when you're ready, please. And then set up puzzle 1.
I'm gonna do all this in head. You still need to write it down.
Then it should be quick to write down.
But you have to write down the X.
No, you could just write the answer.
Oh,
Like,
okay.
so just like just put.
Does that make sense? Yeah, sure.
That's perfect. Writing the answers down is totally fine. Okay. This digital escape is pretty quick, which is great news. And you can definitely work with your team. I just want to remind you of a couple of things. When you multiply, what do you do with the exponents? Add. So this is x to the 7. I just want to be really clear. What letter of the code is x to the 7?
E.
Yeah, x to the 7 is E. Great job. So down here, you put E. Make sure to put that as the first letter of your code. Okay, one more thing I want to say about this. What do we do when we divide? What do we do to the exponents? Yeah, so this would be x to the 6. This is actually not the second one, though. This is the third one. What do we do for the code there? What is x to the 6? What letter? H. Okay, so leave a little space for your second letter, but your third letter is going to be H. Okay, does everyone understand how the digital escape works? Okay, now one more thing. I don't know, just hold on real quick. If you have something like this, what do you do with the exponents? Multiply. Okay, just want to be sure because I know that's coming up. Okay. Hold on 1 second. Hold it together for me. I appreciate your enthusiasm. I do. Just give me one more minute or two or three. Okay. I want you guys to all look at the screen, please. Stop doing your digital escape for just a minute, please, and look at the screen. This is posted to Google Classroom. I want you to know you have a test a week from today in this class. For your test, you can use a 3x5-inch note card, which I will give to you when we get closer to it, or notes and a calculator. Your notes must be handwritten by you and will be collected with your tests. Use both sides, 3x5. These are the topics. Punching machines forward and backward. Do you know what that is? Stating and justifying whether or not something is a function. Do you know what that is? But you also know how to do it with a table. Remember, you're looking for repeating x's to have different y's. Okay. Domain and range. We're all at a different spot with that. Do you know what it is? Well, you don't know what it is, but does everyone else know what it is? I don't know. Well, you should probably study that. That would be a good idea. We got a week. Do you know about solving equations? Okay, that's just like undoing to get x by itself. Order of operations, that's the PEMDAS stuff. So we did minus and negative, we did absolute value. Don't forget, we did square roots and cube roots also at the beginning. Pile pattern, you know what that is? Yeah. That's everyone's favorite. And then the laws of exponents. Those are the chapter test topics. Yeah, well, that's pretty good considering your lengthy absence. I missed you greatly. Okay, last thing, I want to be clear on what I'm stamping right now. So let's take a look. Can you guys everyone in the class get your stamp sheet out? Everyone in the class, the whole class, everybody, tune me back in and get out your stamp sheet, please. Not only do I want to clarify, but this will make things faster when I come to stamp. Okay. There are actually 5 things I'm looking for. Some of you already have some of it stamped. I'm looking for the domain and range scavenger hunt. Some of you have that stamped already. It's okay. I'm looking for 73 to 78. That's on graph paper. 81 to 85 should also be on graph paper. That's from the CPM book. I'm looking for the review notes. We just did that just now. It's in your packet. I'm not looking for the digital escape yet. Okay, last thing. Are you all listening? Because I don't want to have to say this 50 times. I'm going to stamp your warm-ups. One of my complaints from my students is that I don't have a box for the warm-ups on the stamp sheet. But what I do is, please stop talking. What I do is I look at your warm-ups. There should be 26 of them. You're just going to glance. You're going to show them to me. And then I put a stamp right next to the word warm-ups right there. So you're just going to flip, show me your 26 warm-ups, and I'm going to put a stamp next to the word warm-ups. Does that make sense? Okay. So I am stamping warm-ups, scavenger hunt, 73 to 78, 81 to 85, and the review notes. Now take a look real quick, one more thing. The chapter 1 review assignment is due on the 10th, and the closure is due on the 10th. I'm not going to be checking anything tomorrow except for the digital escape. Tomorrow, we will be working on these. They're multiple nights homework, basically. See how it says finish, review, and closure here. So if you're organizationally minded, you'll probably want to write due 9, 10 on those 2 boxes. All right. That's everything I have to say. Now I will stop talking and I will timestamp, and you guys have the rest of the period to work on the digital escape.